Okay, so I'm looking at 4.1.2b, although 4.1.2a is kind of the same stuff. You're trying to simplify these things down as much as possible. It's kind of hard to talk about just because they're all so different. But the main objective that you're really looking at when you're doing these is, number one, to see if you can utilize your identities to simplify things if at all possible. Okay, you want to try to get down to where you have as few a number of trigonometric functions in the final answer as possible. So if we can trade things out using these, make two terms into a single term, those types of things are definitely helpful. That's kind of the overall objective behind these things. Some of these are super fast and easy because they're just straight conversions, and then some of them not so much. So I'm going to take a look at quite a few of these just to give you guys some samples of how to make this stuff happen. But again, I can't really say like this is exactly how you do it because every one of them is going to be looking different. Some of you guys are going to find that you like working in sine and cosines a whole lot better. So if you want to, all of these things can be converted to sine and cosine. So if that makes you feel more comfortable, then do that. If you're comfortable working with your tangents and cotangents and all those types of things, then you can do that as well. I'm going to show you two different kind of ways to do this. One converting to sines and cosines and the other one not. But keep in mind, I know I take it back because these are both super, super easy. So tangent squared of theta plus 1. So that's one of our identities. Right? Anytime you see a squared term and a 1 anywhere near it or just a squared term, think about, can I use my Pythagorean identities? Because even if I just had the cosine squared of theta, sometimes it's beneficial to switch that to the sine squared of theta to 1 minus 1, or 1 minus the sine squared of theta, so that we can get a single trigonometric function. So keep this in mind. We can use these sometimes to expand and sometimes to bring it down to a single term. Just depends on what we're looking at. So like here, tangent squared is just 1 secant squared of theta, so secant squared of theta. And then I've got 1 plus the cotangent squared of theta, which is the cosecant squared of theta. Okay, and then when you think about the cosecant, this is the same as the 1 over the sine, and we talked about the fact that if it's squared, then it's going to be, a cosine, I'm sorry, 1 over the cosine squared of theta. Let me just actually show that to you. So then if I wanted to convert this, 1 over the cosine squared of theta divided by the cosecant as 1 over the sine squared of theta. Okay, so multiplying our fractions, we multiply outsides and insides, or keep it, flip it, change it, whichever way you learned how to do it, that's fine. Outside values would be 1 times the sine squared of theta, so that would give me sine squared of theta on top. The insides would be cosine squared over 1, so that would be the cosine squared of theta. Well, sine over cosine is just the tangent squared of theta. Okay, so I've gotten it all the way down to 1 trigonometric function, so this is going to be the simplest form that I can get it to. Again, there's other ways you can go about doing it. That's definitely the easiest, fastest for that one, because those are already Pythagorean identities, the way that they're listed out. Some of these are pretty quick. I am going to talk about number 2, because they don't really do. I don't see another one that's really like it where you have the 2 functions in the bottom. So I'm going to go ahead and just talk about that. So if I have 1 over the secant of theta minus the tangent of theta minus 1 over the secant of theta plus the tangent of theta. So again, if you are not comfortable working with secants, tangents, all that stuff, you can convert these things to sines and cosines. But I'm going to work with it first here. So one thing when you have 2 different terms like this and everything's a little complicated, sometimes the easiest thing to do is to put them together as a single term. So like here, if I want to get a single fraction, then I'm going to multiply by the secant of theta plus the tangent of theta on this side, top and bottom. And over here I'm going to do the opposite, right? That way I have both, because this is going to be one term. So then I would do secant of theta minus the tangent of theta to the top and bottom. That way I have a common denominator. Okay, so now that I have a common denominator, I can go ahead and I can put the two fractions together. So on top here, I just have the secant of theta plus the tangent of theta, and then minus the secant of theta minus the tangent of theta, all divided by that common denominator, which was the secant of theta plus the tangent of theta times the secant of theta minus the tangent of theta. So by doing that, it allows me to distribute this negative here. So this becomes negative, this becomes positive. So I get secant of theta minus secant of theta, and then I get tangent plus the tangent. So I would get 2 tangent of thetas divided by, now multiplying this bottom part out, I've got the secant of theta squared. The two middle terms will cancel because I'll get a positive 1 and a negative 1. So then minus the tangent squared of theta. So noticing the squareds here, ooh, that is not correct. Don't write it like that. Secant squared of theta, not theta squared. So looking at that, if I look at my identities there, I know that the secant squared of theta is the tangent squared of theta plus 1. So I can create that denominator to only have tangents there instead of having a tangent and a secant. So I'm going to do that. I'm going to replace this with the tangent squared of theta plus 1. So now I am at 2 tangent of theta on top, divided by the secant squared of theta is going to become the tangent squared of theta plus 1 minus the tangent squared of theta. Okay, and then tangent squared of thetas, well, they cancel each other out, and so I'm just dividing by 1, so I end up with just 2 tangent of theta. Okay, so that's one way to go about it. Again, you can also do the same thing and convert it all to sine and cosines. Let me see if you can kind of see that there. Okay, so I kind of did that on this particular paper there, where I took the secant and did 1 over the cosine. I did the tangent as sine over the cosine, so this becomes 1 minus sine of theta over the cosine of theta on the bottom. So then when I keep it, change it, flip it, I get cosine of theta over 1 minus the sine of theta. I did the same thing here. Secant is 1 over the cosine, tangent is sine over the cosine, and it's plus. So now I've got a cosine of theta over 1 minus sine of theta, minus the cosine of theta over 1 plus the cosine of theta. And then getting my common denominator, same as I did with the tangents and everything, multiplying by the 1 plus sine of theta and the 1 minus the sine of theta, gives me the cosine of theta, positive cosine sine, negative cosine of theta, positive cosine sine. That gives me 2 sines, but so I ended up with the 1 minus the sine squared of theta on the bottom, which is the cosine squared of theta. And then the one of those cosines cancels. I kind of did part of that in my head because I had a cosine and a cosine, and I knew this was going to be the cosine squared. So I didn't take the time to multiply it all out. I just had 1 plus sine theta, 1 minus 1 minus sine theta, so that became sine theta plus sine theta, which gave me the 2 sine theta over, I still had 1 cosine theta on the bottom, so sine over cosine went back to tangent. So again, it just kind of depends on where you're at, what you want to do with things, as far as where the problems end up. Okay, so let's see, let's look at a few other ones. Some of these are pretty straightforward. Again, all else fails, if you don't know what to do next, consider just changing to sine and cosine and see what you can do with it. Okay, so I'm going to look at 21. That looks like a good one. So 21, zoom back out a little bit. So 21 is the tangent of theta over the tangent of theta plus the cotangent of theta. So everything's kind of already in the world of tangents, and I do know that cotangent is the same thing as 1 over the tangent. So I could go ahead and do something with that because that seems like easy. What you can't do is cross those out. I see that a lot. but this is being added to this, so this is the denominator, the entire thing is the denominator, so there's no just canceling there. I can, however, convert this a little bit, so I've got tangent of theta, which is the tangent of theta plus 1 over the tangent of theta. So if I multiply this guy over here by the tangent of theta on top and bottom, then that'll give me a common denominator to put those two pieces together, which I like to do. I like to try to get these things into one nice little fraction if possible. So that gives me the tangent squared of theta plus 1 over the tangent of theta. Okay, so either keep it, change it, flip it, or inside, outside, whatever you do, right? So if you're doing inside, outside, this would be the outside tangent of theta times the tangent of theta, which would be the tangent of theta squared, divided by tangent squared of theta plus 1. But that's one of our identities, right? So the tangent squared of theta plus 1 is the secant squared of theta. So I end up with the tangent squared of theta over the secant squared of theta. So I still have two different trig functions, so I can try to break that down. Again, I can either try to convert tangent into secants or just go all sines, cosines, because this would be the sine squared of theta over the cosine squared of theta, all divided by 1 over the cosine squared of theta, because secant is 1 over the cosine. So when you do that, outside, inside, these two things just cancel each other out, and I get the sine squared of theta. It cancels because sine squared theta times cosine divided by the cosine squared of theta divided by the cosine squared of theta makes those two things just cancel out. Okay? So, and again, there's more than one way to go about doing these. I'm just showing you one particular way, trying to give you some skills on how to attack these things. Again, when you're looking at stuff like 23, you're just kind of looking at like simplifying things down, because sine here, tangent is sine over cosine, so this is just sine squared over cosine. So instead of having those two, I created this. Cosecant is 1 over the sine, tangent is sine over cosine, so that's going to, the sines will cancel out, and I just get 1 over the cosine, which I can now easily put together because they've got a common denominator. Sine squared of theta minus 1 is an identity. So that becomes the negative cosine squared of theta, and then divide that by the cosine of theta, and you get negative cosine of theta. So that's one way. There's a few more that are kind of ugly that I wanted to show you. Let's look at 25. Okay, so looking at number 25, so I've got the sine squared of theta minus the tangent squared of theta divided by the tangent squared of theta, sine squared of theta. Okay, so again, lots of different things that you can really do. For instance, tangent squared of theta, we can either do it as secant squared minus 1, that would work. You convert it to sine over cosine, that would work as well. Lots of different ways you can do it. So let's just say that I convert it. I think I did that. Okay, so let's see. So sine squared of theta minus the sine squared of theta over the cosine squared of theta. Okay, and then down on the bottom I've got the sine squared of theta over cosine squared of theta times the sine squared of theta. So that would give me, when I get a common denominator on the top, and there's a reason why I just like to combine to create a single fraction. So I would get sine squared of theta cosine squared of theta minus the sine squared of theta over the cosine squared of theta. And then here I would multiply by cosine squared of theta. Oh, no, I'm sorry. Don't have to do that. So here I've just got the sine to the fourth of theta, that's multiplication. So that would be sine to the fourth power of theta over the cosine squared of theta. So those things are going to cancel there, the cosine squared of thetas. On top here, I can factor out the sine squared of theta. And I would get cosine squared of theta minus 1 by factoring out the sine squared of theta, cosine squared of theta minus 1, divided by the sine to the fourth of theta. So then this goes away and this reduces to 2. Cosine squared of theta minus 1. Okay, so if I move the 1 over to create minus 1, I have to move that way. That would make that negative sine squared. So that would equal negative sine squared of theta over the sine of theta squared of theta, which equals negative 1. It's a whole lot of work to get to negative 1. Yes, I know. But this whole entire ugly thing can be converted down to just the value of negative 1. Again, there's more than one way to go about doing this particular thing. I could have started by changing this to the secant squared minus 1 and kind of gone from there. So if I do that, then the secant is 1 over the cosine, and so you can kind of create that tangent value out of that, which will then eventually cancel out, and you'll still end up with the minus 1. Let's see. So sine squared, let's see if I can do that one real quick, minus the tangent squared of theta. So then if I change tangent squared of theta to secant squared of theta minus 1 times the sine squared of theta, which would be the sine squared of theta minus the tangent squared of theta divided by, so multiplying that out, so secant is 1 over the cosine squared of theta. So that would be sine squared of theta over the cosine squared of theta, which would give me the tangent squared of theta minus the sine squared of theta. That was way faster. So then if I factor out a negative 1, I would get the sine squared of theta minus the tangent squared of theta over sine squared of theta minus the tangent squared of theta. So I just factored out a negative 1 from the bottom here, and they're dividing the same thing, so I get negative 1 as an answer. That was definitely faster. So again, it kind of just depends on what you see. Neither of them is right, and I mean neither of them is wrong. You can get the same answer either way. So a great way to look at the fact that there's multiple ways to go about doing them. As long as you are doing proper mathematics, then you're fine. So if we're converting into identities that are true identities and making sure we're paying attention to negatives and all that kind of stuff, as long as you're doing those things, then it doesn't really matter how you get there as long as you can get there. Let's see. There was another one that was kind of, that I remember doing that was pretty ugly. Oh, 32. Again, 32 has multiple ways to go about it. This is one particular way that I saw it. It is a little messy though. So we don't have anything dealing with the cubes of these things. So sine cubed plus the cosine cubed of theta. 1 minus the sine of theta times the cosine of theta. Okay? So looking at this particular thing, as soon as it focuses back in, I can't do a whole lot as is, but I can split this, because this is the same thing as the sine of theta, sine squared of theta, and this is the cosine of theta, cosine squared of theta. And again, you might find different ways to do this, because there are definitely more than one way to go about doing this. This was just the first way that popped into my head. So this is how I did it. So I changed this because I know that the sine squared of theta is going to be 1 minus the cosine squared of theta. So I've got sine of theta times 1 minus the cosine squared of theta plus the, really a few different ways I can go about it from here too now that I'm looking at it, but I'm just going to keep going with what I already had. So the cosine of theta, and then cosine squared of theta can be the 1 minus the sine squared of theta. all still over 1 minus sine of theta cosine of theta. It's funny is when you go back and do the same problem, sometimes you see a little bit faster way, but I'm going to continue it on this way. But anyway, so sine of theta minus sine of theta cosine squared of theta plus the cosine of theta minus the sine squared of theta cosine of theta. Ugly, I know, but it'll work out here in a second, I promise. So if you like factoring by grouping, then you can factor by grouping. If you like to just factor, it doesn't really matter. Both of them are going to work out the same way here. But if I were to take these two things right here and put them together, so the negative sine of theta cosine squared of theta minus the sine squared of theta cosine of theta. I'm just rewriting this top one. All still over this super ugly bottom here. Okay, so factoring by grouping a little bit here. So on this first little set here, I can take out a negative sine of theta cosine of theta. So negative sine of theta cosine of theta. When I do that, I'm left with the cosine of theta plus the sine of theta. Okay, when you divide out a sine and a cosine from each one of those. And then here, if I take out a sine of theta, I feel like I wrote that wrong. I did. I wrote the same term twice, I'm sorry. This should have been, so I had the sine of theta, it should have been a plus cosine of theta. Just rewriting, doing two things at once in my head. There was sine and cosine, right? Because these two are those two, and then sine and cosine are there. So since it already kind of matches up here, I'm gonna leave it alone. So now I can factor out a cosine sine, right? Call that a 1. So I have this in common between these two pieces now. So I can factor out a cosine of theta plus the sine of theta. And then I've got 1 minus the sine of theta cosine of theta. Okay, because when I factor out here, I get negative sine of theta cosine of theta. Factor out here, I get 1. So I just switch the order so that it's 1 minus instead of negative plus. And then that's still over this ugly thing. But now that they're in perfect factors, these two things cancel. Which would be cosine of theta plus the sine of theta. Again, could be... there are definitely different ways to do it because I kind of saw one when I got started, but that would be one way to go about that as well. So I end up with cosine of theta plus the sine of theta as a final answer for that. But that in general is kind of what you're looking at. Keep in mind that you're allowed to factor things out, right? So like if I'm looking at 35 here, I can factor out a cotangent, bring it to the front. I can reduce things if I want to. So here I got secant squared minus 1, which that's just the tangent squared of theta. And when you do the cotangent times the tangent, those things all just cancel out and you get a 1. Because this would be sine over cosine. This would be this would be cosine over sine. This is sine over cosine. Now, since this is a tangent squared, that means you still have a tangent technically left up there. Which I have written out there as the sine over the cosine, or just the tangent, either way that works. And then you can kind of reduce down here as well. So sine over cosine becomes sine squared over cosine, which becomes sine squared over cosine plus a cosine squared over cosine when you put them together. So the cosines will end up canceling out. Sine squared plus cosine squared is just 1. And so you end up with just the sine of theta once you reduce all that down. So again, there's lots of different ways. Keep in mind that when you're doing the math, you're still doing algebra things to them. They can still be factored. You can factor by grouping. You can just factor them. If you have a square, you can square root just to include your plus and minus. When we start getting into graphs, it does change our domains a little bit when we start talking about things like that. When we're solving things, we have to make sure that everything fits within the domain. when we do stuff like that. But in general, these things react the same way that X values do, or just basic variables do. So keep that in mind. And now we've got all these extra little rules where we can swap things in and out for things that make our lives easier. That's the general objective in all of this, is what can I swap this out to make things cancel to make this thing easier, right? I hope that helps a little bit. I know there's just a ton of them because, again, they're all just different. So the only way to really get the work in that you need is to just kind of keep working on them. But I hope this kind of helps give an idea. Good luck.